Hello class, these are our notes for geometry. Today we're looking at section 10.1, simplifying square roots. So this is going to be a little bit of new stuff, a little bit of review for us today. So the first question, it says find the square root of 40. Round your answer to the nearest tenth. Check to see that your answer is reasonable. So it's really important that when we say square root, we mean this symbol. We do not mean like 40 with the little 2. That's squared. That's not what we're doing. We're doing a square root. So remember, the square root should be the number that if we multiply it by itself, we get 40. So when I take the square root of 40 on my calculator, it gives me tons of decimal places. It gives me 6.32455532. And that's because I have an irrational number. It doesn't even stop. It goes on and on forever. There's no pattern to this, and we can't really write it as a fraction. We're going to round to the nearest tenth. So the nearest tenth, the 10th place would be the 3. And so I want to look after the 3 and decide if I round up or if I round down. And rounding down is really just keeping it as a 3 is what we mean. So we've got to decide if it's 6.3 or 6.4, which one it's closer to. And because the number after the 3 is a 2, we're going to round it down, as we say, to 6.3. So we're just going to keep it at 3. So we're going to say that the square root of 40 is approximately equal to 6.3. And what that means is if I took 6.3 and multiplied it by itself on the calculator, that means 6.3 squared, I would get something really close to 40. I wouldn't quite get 40 because I've rounded my number off, but I would get something really close to 40. So for our first example, I guess that was our first example, but it was more calculator use. For example 2, we're trying to find our side lengths using Pythagorean theorem. I put the Pythagorean theorem in a little box over here if you've forgotten. Remember, C is your hypotenuse. It is the longest side, and it is across from the right angle. So the triangle can be moved around, but that's what we have to kind of look for. Like we could move the triangle so C was at the bottom or something. So you can't just look at it and decide which one's the base. We're looking for the hypotenuse to be across from the right angle, and the hypotenuse is the one kind of by itself after the equal sign there. So for this problem, I would have to take, this is going to be like my A and my B and my C, because this is my hypotenuse, which is called C conveniently. So I'm going to go ahead and write out my Pythagorean theorem. Square root of 2 squared plus square root of 3 squared equals C squared. So squares and roots cancel out. Square root of 2 squared would just be a 2. Square root of 3 squared would just be a 3. So we have equal C squared. So 5 equals C squared. And then the way to get rid of a square is to take a square root. So technically when we have a variable squared and then a square root, it could be a positive or negative. But we're working with a triangle, so we're going to ignore the negative value, and we're just going to use the square root of 5. So it does say to round to the nearest tenth on a calculator. So when I do square root of 5 on a calculator, I get 2.23606. It's lots of numbers, right? But I want to round again to the nearest tenth. So after the 2 is a 3, so I'm going to round it down to just 2.2. Next, we have the product property of radicals. So product property of radicals is just if I have two square roots. So we're going to use this to multiply radical expressions. I guess I want to write something here. Multiply radical expressions. And so what you think of as the square root symbol is really the radical symbol. And sometimes we have little numbers up here to show different roots. But like that hook part itself would be a radical symbol. I have a lot of students that like to refer to it that way. They're like, it's kind of like a division symbol, but it's not. It's a hook. So our example would be that if I have square root of A, I guess I'm just using variables for this, times square root of B, then this would be equal to the square root of A times B. And I think you already know that from our work with simplifying square roots. So what I can do here, square root of 3 times square root of 7, I can just multiply it and I can make it the square root of 21. Square root of 2 times square root of 8 could be square root of 16. But 16 is a special number. I know that 4 squared is equal to 16, so I could make this the square root of 4 squared. And then remember squares and roots always like cancel out. So this is just a 4. So next we're looking at simplifying radical expressions, which again we've already done. So the way we did this was using a factor tree. And we said, let's break down 12 as far as we can go. So 12 was 2 times 6. 6 was 2 times 3. Like these are all of my prime numbers that I could break down 12 into. So 12 is 2 times 2 times 3. So because there's 2 factors of 2, I'm going to write that as 2 squared times 3. So far this is exactly equal to 12. I'm going to keep the square root over all of them. So this means it's the square root of 2 squared times the square root of 3. And we know a square and a root cancel, so this is just going to be 2 times the square root of 3, which is just 2 times the square root of 3, or you could read it as 2 radical 3. We'll do the same thing for 45, but we're going to show a little bit less work. So 45 is 9 times 5, and 5 is prime. I can't break it down anymore, but 9 is 3 times 3. So this is going to be the square root of 3 squared times the square root of 5. So see, I kind of jumped a couple steps there. I didn't write my times sign. I know I can break this down because the 3 squared and the 5 multiply to make 45. And then I can see real clearly, I just have 3 root 5, like this. So the important part is to make sure you have the right number inside my square root symbol. So the 5 stayed inside because it didn't have a pair. It wasn't squared at all. Now we're going to look at squaring a radical. So there's different ways to think about this. I like to encourage students to always just write it twice. That's what squared means. So this means 3 root 7 times another 3 root 7. So I'm going to go ahead and write the 3's together. So 3 times 3, and I'm going to write those square roots together. And of course, the first time we do this, it's always going to be the long way. So the 3 times 3 makes a 9. And then this is going to be the square root. 7 times 7 is a 7 squared. So all I have left is 9 times 7, which is 63. Let's go ahead and try the second one. So I'm going to have 2 square roots of 11 times 2 square roots of 11. So we're going to multiply the 2's together, and we're going to multiply the square root of 11's together. And the 2's make a 4. The square root of 11, we could write it as square root of 121, but it's just really 11 squared. 11 times 11 is 11 squared, but we have that square root. So we have a 4 times 11, which is a 44. So this is where we end for the day. So a little bit of new stuff. I feel like multiplying square roots, you might not have thought about that before, and definitely squaring radicals like this is new as well. So big ideas today are still working with square roots. I think we should probably do a little bit of vocab as well. If I'm looking at the square root of 25, remember this is our radical symbol. And then we do call the number inside the square root the radicand. And we have lots of different kinds of roots. We have cube roots, we have fourth roots. So we use this radical symbol for all of them. Square roots really should have a 2 here, but we use them so often that people just decided to quit writing the 2. So just quick intro to square roots today, reviewing Pythagorean theorem, reviewing simplifying square roots. As always, if you've got questions, please make sure you ask.